Hey everybody, coming at you from West Virginia. How's everybody doing? Alright, so I think it's time for joke of the day because it is the best part of the day. So, my brother didn't like his beard, but then it grew on him. Thank you, JD, for that background music. We got Stairway to Math happening here. So let's stairway ourselves to polynomials. So polynomials, we need to first take a look at a definition of what a polynomial is. It is a finite sum. Now let's back up a second here. What does finite mean? Well, finite is the opposite of infinite, like the infinite galaxy, which is not infinite. But anyways, finite is the opposite of infinite. Infinite means that it goes on forever. And so finite means that there is a definite ending to it. Sum, remember, sum means addition. So what's going to happen here is I'm going to add up a bunch of terms, and fortunately there's an ending to this. It's not going to go on forever. So we have a finite sum of terms whose variables have positive exponents and no variables are in the denominator. Now that part of this is not going to make a lot of sense until we get later talking about the laws of exponents, and then this idea of no variables in the denominator will make complete sense. Because basically having positive exponents and no variables in the denominator pretty much means the same thing. So there's your definition of what a polynomial is. Now what I really want to stress to you right now is we can break down the word polynomial. This part here, nomial, means term. So that's where we get the idea of a finite sum of terms. Poly, you know, means many. So basically a polynomial is going to be many terms. And that's what this definition says. Now when you have a polynomial, you can have a general form of your polynomial, and this is what the general form looks like. I know that this is very scary, but let me kind of break this down for you and show you it's not near as scary as it seems. One thing is, you should be noticing some patterns that you see here. One pattern that I notice, and I'll just give you a minute to look at it and see if you can notice some of those patterns. I'm just going to give you a second to digest it. So hopefully one of the patterns that you're seeing is whatever this subscript is, that's the exponent. This subscript is that exponent. This subscript is that exponent, and so on down the line, subscript, exponent, subscript, and there is an understood exponent of 1 right here. And what you'll understand later as we get into laws of exponents, there would be an x here with a 0 power in it. So subscript exponents. Basically what's happening here is the only thing that's truly a variable in this is all of these x's. Everything else, well, not everything else, but this right here is the coefficient for the x to the n power term. This is the coefficient for the x to the n minus 1, and this is the coefficient for the x to the n minus 2. This is the coefficient for the x squared. This is the coefficient for the x to the first power, and this coefficient for the x to the 0 power. Basically, this is a constant term. Constants are numbers that do not have variables with them. So basically, this is an alignment kind of situation. All it says is this coefficient goes with that variable. This coefficient goes with that variable. This coefficient goes with that variable, and so on and so forth. The second pattern that you are probably noticing is that these are going in descending order, descending coming down, and they're descending by 1. If I take this exponent and subtract 1, I get here. If I take this exponent and subtract 1, n minus 1 minus a 1 will give me n minus 2. And then down here, 2 minus 1 is 1, 1 minus 1 is 0. So it's going in descending order. Typically, you write your polynomials in descending order. So, again, hopefully you're noticing that this is not near as complicated as it seems, because all it says is write your polynomials in descending order, and this is the coefficient for that variable, this is the coefficient for that variable. Now, once you've identified that you do have a polynomial, you can classify your polynomials, and there are 2 ways to do that. One way is by the number of terms. To classify it by the number of terms, you simply look at the polynomial and you say how many terms are there. You need to understand, though, that terms are separated by addition and subtraction. You can have multiplication within a term. You can have division within a term because multiplication and division go hand in hand. But addition and subtraction are what separate them. So, if say for instance down here, here is the subtraction that is separating this term from this term. And so in this polynomial, I have a term sitting right here, and then I have a term sitting right there. In this one, I have a term sitting right here. Here's the subtraction that's separating the next term. Here's the addition that's separating the last term. So once you've identified how many terms you have, you can give names to your polynomials based on the number of terms. Now remember, nomial means term. So if I have one term, mono means one. Like if you have, say for instance, Sherlock Holmes, they had the little lens like this, that was a monocle. Mono means one. If you're talking about speakers, you can have stereo speakers, which would be dual speakers, or you can have mono speakers, which would be one speaker. So nomial means term, mono means one. So one term would be a monomial. And I've got 3 examples here of monomials. Notice there's no pluses or minuses separating any of this. It's just, here is a monomial of just a variable. That's okay. Believe it or not, to only have a number is okay to call that a monomial. And then a combination of numbers and variables could give you a monomial. Now, moving forward, again, if nomial means term, what if I have 2 terms like you see right here? Then I have a binomial, because nomial means term. Bi means 2, like a bicycle has 2 tires. Bifocals, so I've got progressive lenses, but bifocals would be 2 lenses. So bi means 2. And then if I have 3 terms like you see here, 1, 2, 3, there's the subtraction separating, there's the addition separating. If I have 3 terms, then I have a trinomial. Again, nomial means term. So mathematicians got creative 3 times, and truthfully guys, mathematicians are not creative people at all. We call it like we see it. And so we got creative 3 times, and we were completely exhausted after all that, and we needed a nap. So we said, okay, enough creativity there. After 3 terms, we said, you know what, anything beyond 3 terms, we're just going to call it an n polynomial. So in other words, if it has 4 terms, it's called a 4 polynomial. If it's 5 terms, it's a 5 polynomial. So if it has 100 terms, what is it called? Absolutely, a 100 polynomial. So this is how you classify your polynomials, by the number of terms. Now, let's take a look at the second way that you can classify polynomials, and this is going to be by degree. Now, in order to classify your polynomial by degree, you need to know how to get the degree of a monomial. So first, let's take a look. In order to get the degree of a monomial, which would be 1 term, you take the sum of the exponents of the variables. Remember, sum means add. So I'm going to add the exponents, but very careful, only on the variables. So in these 3 examples that I've got right here, I'm going to find the degree of each one of those. So in this first example, to get the degree, remember I want to add up the exponents, but only on the variables. I'm not worried about this coefficient out here. I'm simply looking at the exponent on this variable and the exponent on this variable. And when I take a 2 and a 3 and I add them up, I get a 5. So that is a degree, the degree of that monomial is 5. Let's skip this one for now and come down to this one. So in the letter C example, and this is a square root of 2z, I always put a line through my z's so they don't look like 2's. Anyways, a square root of 2z, remember I want the sum of the exponents only on the variables. And I do want to point out it's okay to have a square root in your coefficient, not a big deal at all. But this is my only variable. I'm going to look at its exponent. When it doesn't look like there's an exponent there, it's understood to be a 1. Just like if you would have a variable and it doesn't look like there's a coefficient on that variable, say for instance I've got a variable sitting like this and it doesn't look like there's a coefficient there, it's an understood 1. Same thing here. So I have an understood 1 exponent. So if that's my only exponent, that means this is degree 1. Now let's come back to this one. Notice there's no variables there at all. So if I had to put a variable in there, but it not really be in there, you'll discover later when we look at laws of exponents, if I have to put one in there, it's like taking an x or any other variable and putting it to the 0 power. So that means that this one has degree 0. A lot of people think that this is going to be degree 1, but if this is degree 1 and it has a variable in there, this can't be degree 1 because it doesn't have a variable. They can't have the same degree when one of them has a variable and the other one doesn't. So like I said, here when there's no variable, it's degree 0. But if I do have a variable with an understood exponent of 1, it's degree 1. So that's how you classify your or not classify, but that's how you find the degree of your monomials. Let's take that and use it to find the degree of your polynomial, many terms. To get the degree of your polynomial, you take the degree of the term with the highest degree. So in other words, you find every single term, you find the degree of every one of those terms. The biggest number you see, that's the degree of the entire polynomial. It's that easy. So I'm going to look at this polynomial right here. Remember, terms are separated by addition and subtraction. So I have a term sitting right here. Here's the addition separating the next term. Here's the addition separating the next term. And here's the subtraction separating the next term. Please understand that the sign in front is the sign that goes. So in other words, this addition goes with this term. It's like it's Velcroed to it and it's stuck to it. It's almost like a name tag. Whenever you go to a meeting, you always put your name tag on the front. You never put your name tag on the back because then I don't know who you are. So you put your name tag on the front, and so the sign in front is the sign that goes, and you do not take that name tag off until you leave the meeting. So the sign in front is going to be the one that goes with it. So here I've got a monomial. I need to get its degree. I only have one variable there, so that means this is degree 3. Here I have 2 variables there. Notice that's an understood 1, and when I add those 2 up, a 2 and a 1 will give me another 3, so this monomial is degree 3. Here I have 2 variables, a 2 and a 2 as their exponents, so when I add 2 and 2, I get a 4, so that's the degree of the third term. And finally, this term in the back, it has 1 variable, an understood 1, it's degree 1. So what's the biggest number that you see? Absolutely, so this is going to be degree 4 on that polynomial. So it's a 4th degree polynomial. Now if I was to classify it by the number of terms, it has 4 terms on it. So what would be its classification by number of terms? Absolutely, a 4 polynomial. Remember we did 3 names. We did monomial, binomial, trinomial, and then we got exhausted and said anything after that is just going to be a 4 polynomial because there's 4 terms in there. But it's also a 4th degree polynomial. Now, remember me saying mathematicians are not creative. We got exhausted because we actually came up with some creative names for monomial, binomial, and trinomial. But we took our nap and we got a flare of creativity again. And we said, okay, let's give these some special names. So if I have a 1st degree polynomial, in other words, the highest power is a 1 in the entire polynomial, I'm going to call it linear polynomial. Linear sounds like what? Absolutely, sounds like a line. So what you're noticing here is if I have a line, then that means it's a 1st degree polynomial. And we just looked at our equations that graph lines, and we saw equations that perhaps look like this, and that graphed a straight line. Notice here, 1st degree, the highest degree is a 1. That's making it a linear polynomial, and you know this graph's a line. Now, degree 2 is what we call quadratic. There's a special way that I can help you remember that one. But degree 3 is what we call cubic. And if you think about it, a cube, if you find the volume of a cube, you've got length, width, and height. So you have 3 dimensions on your cube. So if you have 3rd degree, then it's a cubic polynomial. There are other names beyond this, like 4th degree is called a quartic, 5th degree is called a quintic, and so on and so forth. But most of the time, we just stick with 1, 2, and 3 because we just don't do that much with other polynomials of higher degrees. We typically, at this level, we kind of stick with these 3 degrees. So this is how we identify what a polynomial is, and this is how we classify our polynomials by degree, and then also, as you saw before, by the number of terms. And I hope that helps. Have a great day. Bye.